Hello, welcome back to lesson 2.1 part C. So in this little video, I've got a handful of equations I'm going to solve that are a little bit trickier. Where this first one here in number 6, we have a fraction. Excuse me. Excuse me. And that would be part of step 1B, where it says if fractions are present, consider multiplying both sides by the LCD to eliminate the fraction. So at first, you might feel a little frustrated with the fractions, but if you continue with this strategy, it makes them so much easier. So because I only have one fraction, I can just multiply by this number. So if I multiply over here, 48 times, and multiply this by 48, those cancel. So that makes a 1. So I get K all by itself. So then I just have to go over here and multiply 50 times 48. And we can go to Desmos to see what that is. So 50 times 48 is 2,400. And we want to prove that 2,400 divided by 48 does equal 50. And it does. So let's go back to our paper. Okay, the next one that has a fraction, we have 1, 2, 3, 4 fractions. So we have to come up with a multiple that is a multiple of each of these 2, 4, and 3. 8 is a multiple of 2 and 4, but it's not a multiple of 3. So sometimes multiplying them together works, but I can say 4 times 3 is 12, and 12 is also a multiple of 2. So that will work. If you would have done 2 times 4 is 8 times 3 is 24, multiplying all 3 of them together, that always works. So it's not important that you get concerned about finding the smallest one, the least one. Just find a common one, and that will get rid of all the fractions. So I'm going to use 12. So I'm going to multiply 12 times 1/2 times x, plus I'm going to multiply 12 times 1/4 equals 12 times 1/3 x plus 12 times 5/4. And when I do that, each of these fractions should get eliminated. So 12 times 1/2 is 12 divided by 2. This does not mean 12 times 1 and 12 times 2. It's just you're multiplying straight across. 12 times 1 and 1 times 2. So this becomes 12 over 2x. I'm kind of going the long route on this one. For some of you, this might seem too long, but I want to show everybody the intermediate steps on this first one. Then this becomes 12 over 4 equals 12 over 3x plus 12 times 5 is 60 over 4. Okay, now I'm going to simplify. 12 divided by 2 is 6x. And you might have seen that already. 2 goes into 12 6 times. You might have already been able to skip that step. But if not, go ahead and do that. Multiply it out. 12 divided by 4 is 3 equals 12 divided by 3 is 4x plus 60 divided by 4 is 15. Now we have to get all of our x's to one side. So I'm going to subtract 4x and put them on the left. I'm going to kind of go up here. So I'm going to say, I'm just going to rewrite what I have. And I'm going to subtract 4x. So I have 2x plus 13, and those cancel, and then I have 15 on the right. So now I have my x's all on the left. I have to move my 13 to the right. And because it says plus 13, I'm going to subtract 13. So those cancel. So I have 2x equals 15 minus 13 is 2. And now we're down to just 2 times x equals 2. So I'm going to use my multiplication division property by dividing by 2. So x equals 1. One more fraction. So I only have one fraction and its denominator is 5. So that means I can multiply through by 5 and illuminate my fraction. So if I multiply this by 5a, I have to multiply 2 by 5, and I have to multiply 8 by 5. The entire recipe, the entire equation gets multiplied by 5. So those 5's cancel. That's the idea. So that fraction cancels. So I have a negative 3a plus 5 times 2 is 10 equals 5 times 8 is 40. Now I can subtract 10, and my result is a negative 3a, those cancel, equals 40 minus 10 is 30. I'm just going to rewrite it. And I can use my division. I'm multiplying by the entire negative 3. And negative 3 divided by negative 3 is 1, which is what we want. A equals 30 divided by negative 3 is a negative 10. Now these last 3 problems have decimals in them. You can work around it with the decimal, but I'm going to, similar to the fractions, I'm going to teach you a trick that will make it so you can eliminate the decimals. So find the decimal, the one that has the most decimal places. This has 2 decimal places, this has 1. So we have to move everything the most of 2. So I'm going to move this one 2 to the right so it doesn't have any decimal places. So I'm moving it 2, so I have 7x. And so I have to move this one 2. So I have to create a 0. So this is 140. If you move this one 2, you have to move that one 2. And you're moving them the most number of times, the highest number, to get them to be a whole number. So now my equation is much more simple. 7x equals 140. So I'm going to divide both sides by 7 because I don't have any parentheses and I don't have any additions. So x equals 20. And you can take 20 and multiply it by 0.07 and you will get 1.4. Okay, number 10. I have 1 decimal place, 1 decimal place, 1 decimal place. So I am going to move the decimal to the right on each of them once. So this just becomes, that means these zeros on the left can go away because they're only there as a placeholder. So this is a negative 3y plus 1 equals 5. And now I'm back to solving one of a more simple equation. So I have to subtract 1. My result is a negative 3y equals 4. And then I'm going to take that up here, and negative 3y equals 4. And so I have to divide by a negative 3. So y equals a negative 4 thirds. And you might be saying, well, the negative was on bottom. Why is the negative on top now? The number is negative, whether it's in the numerator or denominator. And I just like to move it so it's in the denominator. Okay. number 11. I am going to first distribute this 0.10 times the 15,000 before I move my decimal place, because otherwise I have to worry about other decimal places. So let's first write this as 0.12x plus, and then I'm going to multiply this here. So that was 0.10 times 15,000. That's 1,500. Minus, and then we have to distribute the 0.10. So I'm going to go back to my paper for a moment. So I distributed that, and then I have to distribute to the x. So it's minus, and then 0.10x equals 1,600. Okay. Now, once I eliminated the fractions, then I can go ahead and count how many decimal places I want to move everything. So I'm going to move my decimal places 2 for this 0.12 and 2 for the 0.10. So when I do that, I have 12x plus, I also have to add 2 zeros to this. So this is 1,500 plus 2 more zeros minus 10x equals, and I have to add 2 zeros here, because I moved my decimal place to bigger so that I would have whole numbers. I have to do that for these. Okay. So let's combine our x's. I have 12 positives minus 10. So I have 2 x's plus 150,000 equals 160,000. So I'm going to subtract my 150,000 from both sides. And my result, I'm going to put up here, is 2x equals 160,000 minus 150,000 is 10,000. And then to solve for x, I'm going to divide by 2. So x equals 5,000. And you can check your answer by putting x back into your equation. Okay. The last little piece to lesson 2.1. This is a really long lesson, but we're just getting started. I want to make sure that you have plenty of examples to support your understanding. Identities and equations with no solution. Okay. There are two special cases associated with solving linear equations in one variable. One is this. So if we were to solve this equation here, we would use our distributive property to get 6x minus 8. We're going to distribute equals 3 plus 6x. Then if we subtract 6x from both sides, it ends up canceling both of the 6x's, and we end up with a negative 8 equals 3, which is not true. It's a false statement. So that means there is no solution. Sometimes it happens where you get a false statement. That means there's no solution. That is a possibility. Let's look at example 11. So example 11, we have to distribute here. So we have a negative 15 plus 3x equals 3x minus 15. So if we subtract 3x from both sides, they cancel, and then we end up with a negative 15 equals a negative 15. So that means that it's an identity. When there's no variables left, that means any number that we put in for x into the original equation will equal. So that means every x is true. It's an identity. Every x makes the equation true. So let's look at a couple examples here. I'm going to use my distributive properties. So we have 3x minus 6 equals 3x plus 12. So when I move my x's, I'm going to subtract 3x to move them over here. But the result is, it looks like they both just cancel. So the result is a negative 6 equals 12, which is not true. So that means there's no solution. Now on the next one, we're going to distribute. So we get 7x plus 14, and then I have to distribute here. So I have a minus 8x plus 4 equals 18 minus x. So remember, on the left-hand side, I'm just combining my like terms. There's 7x and a minus 8x. So that when I combine those, I have a minus x left over. And then I have 14 and 4 is plus 18 equals 18 minus x. I'm going to use my commutative property here just to rewrite this with the 18 on the left. And look at, I have identity. I have an exact same equation. So this one is an identity. Any x will make this equation true. So it could be no solution, or it could be an identity, or it could be one solution. So the last two examples I'd like to do are examples that are more like story problems, because life is a story problem. And so we have to get used to taking on a challenge, and that's okay. So this one is about fuel economy. Fuel economy affects us if we own a car, on how far our gas will take us. The combined city and highway fuel economy in miles per gallon, you'll see that on car labels as MPG, for certain automobiles is related to the automobile's curb weight by the formula. F equals a negative 0.004 W at 40 plus 40, where F is the fuel economy and W is the curb weight in pounds. Solve to find the weight of a car that has a combined fuel economy of 25 mpgs. So they want us to solve means that we need to solve for a letter, but I don't know what letter I'm solving for. It says the combined fuel economy is 25 mpgs. mpgs, they said, was F. F is the fuel economy. So this is F. So I'm going to replace that in my equation. So 25 equals negative 0.004 W plus 40. Okay, now I need to solve for W, which is the weight. So I'm going to move my decimal 3 to eliminate this decimal. So I'm going to add 3 zeros to 25. And then this will just be a negative 4W when I move my decimal. Plus, I have to add 3 zeros to 40. Okay. So to solve for W, I'm going to move my constant to the left. So I'm going to subtract 40,000. So my result is 25,000 minus 40,000 in decimals is a negative 15,000. That feels weird that it's negative, but then on the right, we have a negative 4W. So it'll work out okay. We're solving for W because we're going to divide by that entire negative 4. And so we're going to divide by negative 4 here as well. So when you divide a negative divided by a negative, it becomes a positive. So that will work out. Let's go back to Desmos and just make sure that we've got this. a negative 15,000 divided by negative 4 comes out to be 3,750. £3,750. $3,750. LB is a symbol for pounds. And then the last example says solve to find the weight of a car that has a combined fuel economy of 30 mpgs. Okay, so now we're going to do the same thing we did up there, but 30. So again, adding zeros or 3 zeros. So we're going to subtract our 40,000 again. And our result is a negative 10,000 is a negative W. And then to solve for W, we have to divide by negative 4 again. So we can go back to decimals and we just have to change that to dividing by a negative 10,000 instead. So I can just change that to be, instead of a negative 15, it's just going to be a negative 10,000. So the weight of this car is 2,500 pounds. LB per pound. Okay, that concludes lesson 2.1. The rest of the lessons will not be this long. I just wanted to make sure that you had plenty of examples to get you going.